Welcome! In this video, we will learn the partial sum formula for a geometric series, how to determine convergence, and how to find the exact sum when it converges. A geometric series is a list of numbers where each term is found by multiplying the previous term by a fixed number called the common ratio r. The basic form looks like ar squared, ar cubed, and so on. The sum of the first n terms is called the nth partial sum, s sub n. For the series sum from k equals 1 to infinity of a r to the k minus 1, the partial sum formula is s sub n equals a times 1 minus r to the n over 1 minus r. Let's see why this works. Start by writing s sub n as a plus a r squared all the way to a r to the n minus 1. Multiply both sides by r, which shifts every term. Subtract the two equations. Almost everything cancels. Factor out s sub n. Finally divide by 1 minus r to get the formula. Now, how do we determine if a geometric series converges? It converges if the absolute value of r is less than 1. That is, the magnitude of r must be between -1 and 1. In that case, r to the n goes to 0 as n goes to infinity, so the infinite sum becomes over 1 minus r. If the absolute value of r is greater than or equal to 1, the series diverges. Example, does the series 10 plus 5 plus 2.5 and so on converge? The first term is 10, and the ratio is 1/2. Since the absolute value of 1/2 is less than 1, it converges. The sum is 10 over 1 minus 1/2, which equals 20. Now, let's do hidden geometric series examples. Example 1. Sum from n equals 1 to infinity of 3 times 2 to the negative n. Using the ratio of consecutive terms, the ratio is 1/2. Using exponent rules, 2 to the negative n equals 1/2 to the n, so r is 1/2. This converges, and the sum is 3. Example 2. Sum from n equals 1 to infinity of 5 to the n plus 1 over 6 to the n. The ratio of consecutive terms gives 5/6. Rewrite as 5 times 5/6 to the n. This converges, and the sum is 25. Example 3. Sum from n equals 1 to infinity of -2 to the n minus 1 over 3 to the n plus 1. The ratio gives -2/3. Rewrite as 1/9 times -2/3 to the n minus 1. This converges because the absolute value is less than 1, and the sum is 1/15. Example 4 is a divergent case. Consider sum from n equals 0 to infinity of e to the n over 2 to the n. This is the same as e over 2 to the n, so r is e over 2. Since e over 2 is greater than 1, the series diverges and has no finite sum. Summary: the partial sum formula is a times 1 minus r to the n over 1 minus r. If the absolute value of r is less than 1, the infinite sum converges to over 1 minus r. Otherwise, it diverges. Thanks for watching.